Hi, can you hear me? Hello.
Hello.
Yeah, you can hear me, right?
Yes.
Okay, so I had given a couple of questions, I think, in the last class for number theory.
Yeah.
What was the first one?
Prove that there is only prove that there is only one three-digit number n satisfying the relation that n is equal to the sum of n's digits plus the sum of n's digits cubed.
Hmm. Prove that there is only one three-digit number. Sum of n plus sum of n whole cube. Here, sum of n is equal to sum of the digits of n.
Yeah.
Okay, so did you try this one?
Yeah. I did some of it, but I need help.
Okay, so what have you done so far?
So I wrote that n is equal to 100a plus 100b plus 100c. So then 100a plus 100a plus 10b plus c is going to be equal to a plus b plus c plus abc whole cubed.
Okay.
And then you get that 99a plus 9b is equal to a plus b plus c whole cubed. But then you just have to do trial and error from there. So I don't know. Is there like a structured way to do it except for trial and error?
It's not trial and error. It's never trial and error. You can't solve it by trial and error.
Yeah.
You have to think of the fact that when you write it as a three-digit number, A, B, and C are all integers, are all positive, or maybe B and C could be zero, but they are greater than equal to zero integers, where A is greater than zero. B and C could be zero.
Yeah.
If they are integers, and they are positive integers, then obviously you can say what is the maximum value of this,
When A is 9 and B is 9.
right? So we can figure out what is the maximum possible value of this, and then we have an upper bound on this, right?
Right.
So what is the maximum value? 99 into 9 plus 9 into 9.
Yeah.
So that becomes 891 here plus 81, so 972.
Right.
So we know for sure that a plus b plus c whole cube is less than or equal to 972,
Yeah.
which gives us the upper limit of a plus b plus c.
Oh, okay, yeah.
We are getting a plus b plus c must be less than equal to 9,
Right.
because 9 cube would be 9 into 9, 81 into 9. But 9 cube is basically 81 into 9, which is less, much less, 729, but 10 cube is bigger.
Yes.
So it cannot be equal to 10 for sure, right? A plus
Yeah.
B plus C cannot be equal to 10. So A plus B plus C is less than equal to 9 we are getting. right?
Right.
That's one thing we have gotten. We also have the original relation is equal to 99a plus 9b. Now, obviously, if we have an upper limit, we can also try to get a lower limit somehow, right?
Yeah.
So what is the lowest possible value of this?
0.
No,
Or when A is 1 and B is 1.
no.
So A
Think
is 1 and B is 0.
properly. B can be 0, A can be 1, A cannot be 0.
Yeah.
So it is greater than 99 into 1 plus 0, right?
Right.
So now we are getting a lower limit for A plus B plus C. Clearly, A plus B plus C has to be greater than or equal to 5.
Yeah.
Uh, can it be? It is greater than 4 for sure. Uh, can it be 4? No. 4 cube would be 64. So 64 would not satisfy this, right?
Yeah.
So we are getting 5 is less than equal to A plus B plus C is less than equal to 9 now, right?
Yep.
Okay. So now that is all we could do from this relation. We have found a lot of things, but still still have to do something more because this still doesn't give us the number very easily. So the next thing you can think from here after doing upper bound and lower bound is that the right hand side here, RHS, is divisible by 9.
Right.
It is obvious that this is divisible by 9. So obviously this also has to be divisible by 9.
Yeah.
So we know that 9 divides A plus B plus C whole cube. So if 9 divides A plus B plus C whole cube, we only have a few numbers here be which will give us this that 9 should divide the cube, right? Think
Right.
about it. You need at least 1 3 at least.
Yeah.
If you take 5, 6, 7, 8, 9, the only options for us are you cannot take A plus B plus C is equal to 5. You cannot take 7. You can't take 8, right?
Right.
So don't. If you take it as 5, 7, 8, do you get cube of it is divisible by 9? No, right?
No.
So the only things left are A plus B plus C can be 6 or can be 9. In both of those cases, 9 will divide A plus B plus C whole cube, right?
Yes.
Okay, so now let's try to make up a number where the sum of the digits is 6. A plus B plus C is 6. So now that we have only two cases, we can do each case separately. So then here what will come? 216 is equal to 99A plus 9B, right?
Yeah.
The sum of the digits is 6. Also, from the initial condition, you can write A plus B plus C is equal to. Actually, we can just get the number directly because we know the sum of the digits. The initial condition is better because that gives us something like this. If you remember the initial condition, the 3-digit number. Now we have used this result enough. We don't need to get back to this result. Now we can write the initial condition.
Yeah.
We know the sum of the digits is 6 or 9. So the number can be 6 plus 6 cube, which is 222, or it
Right.
can be 9 plus 9 cube,
Yeah.
right?
Right.
So that will be 738. But when you check 222, so actually, when you check 738, the sum of the digits is not 9 here. The sum of the digits in, if you take it, should be 9, but when you put it in this result, you're getting this number. You're not getting sum of the digits 9, you're getting 18. Do you understand what I'm saying?
Yes.
A plus B plus C is equal to 9 does not work out when you do it in the original conditions of the problem. When you do, you get 738. That's not the correct number because the sum of the digits is 80.
Right.
But A plus ABC, if you took as 222, the sum of the digits is also fitting as 6 and it is
Yes.
satisfying the original condition of the problem. So the answer is 222. There is nothing here that is trial and error. Do you understand what I'm saying?
Yes.
It's not guessing and all. It's once you get this equation, you have to think of what are the upper limits, lower limits. From there, we got this much information. Then we can see clearly that the right hand side is divisible by 9 and left hand side also must be like that. From there, we got that A plus B plus C has to be either 6 or 9. And
Right.
automatically, if you have two options, you can write the numbers that come them and check whether they satisfy all the conditions or not. Correct?
Right.
Okay. The next question was find all 3-digit numbers. Did I give this question?
Yes.
ABC such that ABC is equal to 6 times A minus B plus C whole square. Okay, you have to find all the 3-digit numbers which will satisfy this condition. Here, when I write the number like this, that basically means 100A plus 10B plus C, right?
Right.
Okay, did you get any number?
So I did the same thing. I did like 100A plus 10B plus C equals 6 times A minus B whole squared. And I got that 100A plus 10B plus C equals 6A squared plus 6B squared plus 6C squared minus 12AB minus 12BC minus 12CA. But
Expanding
then
it
I,
doesn't help. If you expand the square, there's nothing you can do after that. What will you do then? The question is not like a pure algebra question. You can't solve an algebra question with one equation and three variables.
right.
You are still not thinking in a way of using number theory. You can't solve this by brute force. You understand what I'm saying?
Yeah.
So there is no point to expanding the square. You have to think in terms of like, okay, what are the properties of 3-digit numbers? Just like the previous problem. We didn't just solve it by solving an equation. We saw okay, what are the left hand side looking like? What is the right hand side looking like? What can we figure out from that? Do you understand what I'm saying?
Yeah. So you can say that 100A plus 10B plus C is a multiple of 6.
Right, that is one thing we know. So we have many things we can think here. So first of all, when we write a number like this, we know A is not equal to 0, and we know B and C are greater than equal to 0, could be 0, right?
Yeah.
So what is the possible values of A minus B plus C? What is the range of values of A minus B plus C?
Mm,
Smallest to largest.
smallest would be A is, sorry, smallest would be 1 and largest would be, wait, no, smallest would be yeah, it would be 1 and then 9.
No, smallest is wrong. Think about what are the possibilities of each of these numbers.
Oh, smallest would be -7. Oh, 0, right. So -8.
This should not be difficult, no, to figure out.
Yeah,
A cannot be smaller than 1. You have to put 1 for it. But B can be as large as 9.
right.
C can be 0 also. The largest would be 9 minus 0 plus 9, right?
Yeah,
So this is -8 and the largest is 18, right?
right.
So why am I doing that? Because that will give me a upper bound and lower bound of this side, right?
Right.
So basically now we can see that uh, this is square of this is 64 and square of this is 324. So 6 into 64 and 6 into 324, something like this. Correct?
Right.
Uh, okay, right. Okay, so let's just calculate those numbers once. So 6 into 64 will become 360 and 4 6 are 24, so 384. And this is 6 into 324, which will be 1800 and 144, so 1944, right?
Right.
So that is the limit in which this number has to be between, right? So
Yeah.
notice that this upper limit is even becoming 4-digit, right? So you need only 3-digit numbers, right? So our number has to be between 384 and 999, right?
Yeah.
Because otherwise it will become 4 digits after that, right? So we are getting 384 is less than equal to our number, less than equal to 1944 technically, but actually less than 999. Correct?
Right.
Okay. Then what else can we think about here? So, right. One thing we know is that our number has to be divisible by 6 also. That is also something we can see, right?
Yes.
So 384 clearly is divisible by 6. The highest number that is divisible by 6 would be 960 and 36, so 996, right? Correct?
Yes.
So it is not 999, it's 996, and only multiples of 6 we have to worry about, right?
Yeah.
So basically our numbers are out of these 384, 390, 396, so on till 996, right? Only multiples of 6 are allowed.
Right.
Okay. So we have already eliminated so many of the numbers, by the way. Do you realize that many of the numbers from 100 to 999 have been eliminated already?
Yeah.
None of this would come if you expand it and all. Nothing will come from there, right? So far, what we have done is done lower limit, upper limit, divisibility. These are the types of things you have to think of. Do you understand what I'm saying?
Yes.
Okay. Now, another trick you can do here is this 100A plus 10B plus C. I have a A minus B plus C here, so I can try to create another A minus B plus C on the left-hand side also. For example, I can write it like this. 100A can be written as 99A plus A, right?
Yeah.
And 10B can be written as 11B minus B, and plus C can be written as C only. So you can see easily that this is basically 99A plus 11B plus A minus B plus C, right?
Yes.
Why am I doing that? Because on the right hand side, I have this square. So on the left hand side also, I can create a similar term and then I can take it to the right hand side, right?
Right.
Because then I will be able to take A minus B plus C common sort of,
Yeah.
right?
Yes.
So I will say it is 99A plus 11B plus A minus B plus C is equal to 6 times A minus B plus C whole square,
Mm-hmm.
right?
Yeah.
So I can say 99A plus 11B is equal to bringing this to the other side and taking A minus B plus C common. You will get 6 times A minus B plus C minus 1, right?
Right.
Okay. And for now, for simplification, we can call T is equal to A minus B plus C as one variable. We know the values of T can range from minus 8 to 18. We already figured that out, right?
Yeah.
Upper limit and lower limit of this, we know what is the values of it, right?
Right.
So we can write it as T 6T minus 1, right? That is equal to 99A plus 11B, right?
Yes.
Great. Now, look at this equation. This equation gives you additional information about T at least. Because on the left side, can you tell me something about the left side here?
It's divisible by 11.
Right. Divisible by 11. So now on the right side should also be divisible by 11 somehow, right?
Yes.
So what are the basic numbers that we can take which will make the right side also divisible by 11, right?
Yeah.
That's what we'll try to figure out. T can be any integer from minus 8, minus 7, minus 6, minus 5, minus 4, so on
Yeah.
till 18.
Yeah.
So obviously 0 is always divisible by any number. So if T is 0, the right side is divisible by 11, right?
Yeah.
T can be 0. This fraction cannot be, this bracket cannot be made 0 because T cannot be 1 by 6. So there is nothing you can do with that. But you can
Yeah.
make T equal to 0 for sure, right?
Yes.
Now it is a matter of a little bit of trying out some numbers and seeing the pattern. For example, if I put T is 2, you get 2 into 12 minus 111, right?
Yes.
So 2 is also allowed, right?
Right.
11 will obviously be allowed, T is equal to 11, right?
Yes.
Okay, so 0 to 11, and what else will work? So 12 won't work. 12 into 72 minus 1 won't work. 13, if you do 13 into 6, 78 minus 1, 77. 77 is divisible by 11.
Right.
13 will work. Then you can check like this. You have to check till 18 if there is anything else that works. And you can also check lower numbers. Lower numbers are not working. For example, minus 6 and all. Minus 6, nothing is working.
Yeah.
So ultimately, here you have to try out some values and figure out which values of t work. And you will realize that these are the only four values that are working. Right? So this is the place where you have to try out a little bit. But once you figure this out, that these are the only possible values of t, now we just need to check what happens if I take t is equal to 0, for example, right? Do you understand what I'm saying? What number are we getting when we take t is equal to 0, right?
Yeah.
So in that case, we have basically this part is equal to this is equal to 0 and 0, right? So we'll get 99a plus 11b is equal to 0, correct? So basically you'll get 9a plus b is 0. So b is equal to minus 9a, right?
Yeah.
b is equal to minus 9a. That doesn't seem like possible because a has to be 1. So then b will be minus 9. You cannot put negative integers there, right?
Right.
Do you understand what I'm saying?
Yes.
So that doesn't seem possible. You cannot make a number now, right?
Yeah.
You cannot put negative integers there, right? So this doesn't work. Similarly, if you try t is equal to 2, so a minus b plus c is equal to 2 if I try, I'm getting 99a plus 11b plus 2 is equal to 6 into 4, 24, right? So I'm getting 99a plus 11b is equal to 22, right?
Right.
Dividing by 11, 9a plus b is equal to 2. Again, not possible because b is negative now. Do you understand why it is not possible?
Yes.
Because a has to be 1, and after that, you cannot do anything with b, right?
Right.
Similarly, 11, if you try, so you will get 99a plus 11b plus 11 is equal to 6 into 121, which will be, let's write it like this, 6 into 11 square. You can cancel 11 from both sides, right? So
Right.
9a plus b plus 1 is equal to 66. So 9a plus b is equal to 65, right?
Right.
Okay,
Right.
so here it seems like something could happen here. Uh, right, 9a plus b. Also, you also have, remember, don't forget the original equation. Original equation was ABC is equal to, the number ABC is equal to 6 times of this square, right? This was the original equation, right?
Right. Yeah.
So if I put 11 here, I can get the number directly, right? T is 11, no, T was this, right?
Yes.
So you'll get the number directly is equal to 6 into 11 square. So 121 into 6, so 726, right?
Right.
Correct.
Yeah.
Now notice that the number 726 fits the condition that a minus b plus c is 11. See? correct?
Yeah.
726 fits the condition that a minus b plus c is 11, and it also satisfies everything else that we have seen so far. It's a three-digit number. It is divisible by 6. It is having sum of the digits is 11, which is a valid answer. And we are able to see that it satisfies all the properties. So this is one answer, right?
Yeah.
If you take 13, the number becomes bigger than three digits because you'll get 6 into 169, which is bigger than 1000.
Right.
So 13 is also rejected because we are looking for three-digit numbers, right?
Yeah.
So our answer here is 726. That's the required number. Again, what we did was divisibility. What we did was upper and lower limits. Then we did a thing where we had a minus b plus c this side. So we made a minus b plus c this side also, right? And
Yeah.
we took it to one side and we were able to get 99a plus 11b is equal to t into 60 minus 1, where t is
Yes.
a minus b plus c. And from there we got another divisibility by 11, right?
Yeah.
Which was earlier not there. So that also helped us get some additional information that gave us, out of the possible values of t, we got only four values of t which make it divisible by 11, right?
Right. Yes.
So that is the solution. Do you understand what we have done?
Yes.
Okay. The next question is this: find the greatest 10-digit number divisible by 36. And the greatest 10-digit number which is divisible by 36. So again, the thinking process is important. So you should realize that 36 is 9 times 4. So whatever number you create should be divisible by both 9 and 4, right?
Right.
The reason is because 9 and 4 have no common factors between them, right?
Yes.
3 square and 2 square. So you need to ensure that the number 36, whatever number you create, has to be divisible by 3 square and 2 square, right?
Yes.
Okay. So we have to find the greatest possible number that is divisible by both 9 and 4, right?
Yes.
Okay. Now, how would you do that? You have to think of that.
Well, we know the divisibility rule of 9 is that the sum has to add up to 9. And
Hmm.
then the divisibility rule of 4 is that the last two digits
Hmm.
should be divisible by 4.
Right.
So,
Also think that you have to make the largest possible number, right?
yes.
10-digit number. So obviously, if you start with, for example, if I make a very big 10-digit number, I can start with nine nines, right?
Yeah.
Nine nines, and then last digit is left. And if you want to make it divisible by 9, the last digit can be 0 or 9.
Yeah.
Do you understand?
Right. Yeah.
Because sum of the digits, in order to be divisible by 9, the last digit also has to be either a 0 or a 9, right?
Right.
If you
Yeah.
take any other number, the sum will not be divisible by 9.
Right.
But to make it divisible by 4, the only possibility is 6 at the end. Because then only you'll get 96 as the last two digits, right?
All right. Yeah.
96, 90, actually 92 is also possible, right? Because
Yes.
92 is divisible by 4. So 92, 96, and that's it. Nothing else is possible, right?
Yeah.
So you clearly see that there is a contradiction. You can't fit both, right?
Right.
So you cannot start with 9 nines.
Yeah.
That is not working out for us, right?
Right.
But the strategy is the same because starting with nines is the way to make the biggest possible number, right?
Yes.
So if you can't do 9 nines, let's try 8 nines, right? We have put 8 nines and now two digits are left at the end, right?
Right.
So obviously this part, the sum of the digits is anyway divisible by 9. So we need to select two digits such that their sum is divisible by 9 and also they are divisible by 4, right?
Yeah.
So now if you think about it, what now it is very easy actually. Think about it. Last two digits have to be divisible by 9. So
So
36
36.
is possible, right?
Yeah. And then
72 is also possible, right?
right. Yeah.
Basically, last two digits can be 36 or 72, no? Nothing else is possible actually. Because the last two digits will be like divisible by 36 then. You have to make them divisible by 9 also and 4 also, right?
Yeah.
Do you understand what I'm saying?
Yes.
So the largest number will be the one that you make with 72, right?
Right. Yeah.
That's the answer. So actually like looks very difficult and all, but if you hit upon the right idea, it's quite easy. The
Right.
main thing is not to start from like small numbers. You have to start with the biggest possible numbers. Start from there. Then you will get to the solution quicker. Right?
Yeah.
Okay. So this is the answer for this one. Let's move on to the next problem. We have find all quadruples of digits A, B, C, D such that ABCD number is divisible by 9. The number ABDC is divisible by 16 and the number ACBD is divisible by 25. So three conditions are given and you have to find all the possible quadruples of A, B, C, D. So try it out.
Yeah.
it will be useful for you to remember that whenever a number is divisible by 25, the last two digits of it must be divisible by 25. Basically, it has to be 0, 0, 25, 50, or 75.
Okay.
Like these two rules you need to know, the divisibility rules, where a natural number, I think I had mentioned it before, natural number is divisible by 5 power n if and only if the number formed by its last n digits is divisible by 5 power n.
Yes.
So right now n is 2, so you are getting 25. So number formed by its last two digits is divisible by 25. And similar property exists for also for 2 power n. A natural number is divisible by 2 power n if the number formed by last n digits formed by last n digits is divisible by 2, is divisible by 2 power n. So that's
So,
why when you do 4, you have to check last two digits, right?
yeah,
When you do 8, you have to check last three digits should be divisible by 8.
right.
And when you do 16, for example, you have to check that last four digits are divisible by 16.
Yeah,
So both of these properties are very similar, and these two divisibility rules you must know.
yeah.
That will help you solve the problem. Otherwise, it will be annoying. You should start the problem by thinking of this one.
Yeah, so we know that BD has to be either 0, 0, 2, 5, 5, 0, or 7, 5.
1 second. So, why am I saying start from here? Why do you think I'm saying that? Why not start from here or here?
Because it's the one that gives us like definite numbers.
No, not just that. The fact is that it will give us the smallest number of cases.
Yeah,
If you think of the other conditions, they are not giving us such few situations, right?
yes,
So here we are getting case 1, BD can be 0, 0. Then case 2 is BD can be 2, 5, right? Case
yeah,
3, BD can be 5, 0. And case 4, BD can be 7, 5, right?
yes,
And now in each of these cases, we have to make the other things also happen, right?
right.
So you should start like that. Now think of, okay, if BD is 0, 0, then let's think how can we make this divisible by 16, for example,
Mm-hmm.
right?
Yeah,
And also this divisible by 9.
right.
So just put 0, 0 for BD there. So you'll get the number A00C has to be divisible by 16
Right.
and A0C0, right, has to
Yeah,
be divisible by 9.
right.
Okay, great. So then we know that A plus C has to be divisible by 9.
Yes.
A plus C is divisible by 9, and we have to make sure that this number, 4-digit number, is divisible by 16, right? So if it is divisible by 16, then obviously it is divisible by 8, right?
Mm-hmm.
Do you understand what I'm saying?
Yeah,
Why am I saying that? Because the divisibility of 8 would be done if you check the last 3 digits, right?
yeah,
Why the property that we discussed earlier, right?
yeah,
So last 3 digits of it is 00C, right?
yes,
So the only possibilities for C are 0 or 8, right?
right.
Then only you will get it divisible by 8, no?
Mm-hmm.
So if you check C is 0, then A must be 9, right?
Yeah,
Do you understand?
yes,
So if C is 0, A is equal to 9, but then when you check the number is becoming 9,000, but that is not divisible by 8. 9,000 is not divisible by 16. It is divisible by 8, but not by 16.
right.
It has to be divisible by 16, right?
Yes,
9,000 will become divisible by 8 because last 3 digits are 000. You can check it. It is 1,125. 1,125 into 8 is 9,000.
yeah,
But it is not divisible by 16 because 1,125 becomes odd, right?
right.
So we'll reject that case and we'll take the other case where C is 8, then A is 1, right?
Mm-hmm.
And in that case, our number here is becoming 1008, right?
Yeah,
So that is divisible by 16 because it is 126 into 8, which is obviously 63 into 16. And here the number is clearly divisible by 9 because all the other digits are 0, 0, right?
yeah,
So case 1 we solved and we found the possible numbers. A is 1, B is 0, C is 8, D is 0, right?
yes,
And similarly, you can solve the other cases also and get all the possibilities, right?
right.
Do you understand how we did case 1?
Yes.
So you have to do the rest, you can solve the rest. Find all the other numbers possible,
Okay.
right?
Yeah.
Now, I'll give you a few problems for the next class. Try these out, okay? So
Okay.
Just write down the questions right now. The
Okay.
first one is find the least positive integer n that offers a counter example to the statement if the sum of the digits of a positive integer n is divisible by 27, then so is n. So basically, you have to find the least integer which does not satisfy this, right?
Yes.
So obviously, in the beginning, if you see some integers, you will might get it is working out, right? Sum of the digits of the integer is divisible by 27, then the number is also divisible by 27.
Yeah.
You have to find the smallest number where it doesn't work. That's the meaning of what he's saying. Least positive integer n, which is a counter example, right?
Right. Yeah.
Okay, problem 2 is how many three-digit numbers capital N have the following property. The difference between capital N and twice the sum of its digits is divisible by 7. Okay, so you have to find how many such integers are there, three-digit integers which satisfy this property.
Yeah.
Okay, problem 3 is find the least positive integer n, least positive integer n, such that the sum of the digits of n and the sum of the digits of n plus 1 are both divisible by 5. Okay. Tell me when you have written down these three.
Yeah. I wrote them down.
Okay. Problem 4 is a number is called nice if it has distinct digits, distinct digits, and they can be divided into two groups, two groups, so that the sum of the digits in each group is the same. In each group is the same. For example is the number 67890. It's a nice number because all the digits are distinct and 6 plus 9 plus 0 is equal to 7 plus 8. Right?
Yeah.
And then the follow-up question is, okay, right now we just have the definition. We don't have a question yet. So the question is, can two consecutive 5-digit numbers, can two consecutive 5-digit numbers be nice? Okay, so that is the question.
Okay.
Okay, then problem 5 is find the greatest positive integer with distinct digits such that the sum of any three of its digits, any three of its digits is different from 19. So slightly strange way of saying the problem. Any three of its digits should be different from 19,
Yeah.
and you have to find the greatest such number. Okay.
Yeah.
Have you written this down?
Yes.
Okay. Problem 6 then. Find the least positive integer whose last digit is 1, whose last digit is 1, and having the property that if this digit, if this digit is moved to the beginning of the number, moved to the beginning of the number, then we get a number 3 times smaller than the initial one. Okay.
Yeah.
And last question, find all 3-digit numbers n such that the sum of the digits of n is 3 times the sum of the digits of n plus 3. So that is the last one. Sum of the digits of n is 3 times the sum of the digits of n plus 3. We have to find all such 3-digit numbers. Okay. Have you written it down?
Yes.
Okay, so you need to try all of these questions. We
Mm-hmm.
are almost done with the first part of the course where we just understand numbers and all. The next chapter of the course would be division theorem and divisibility, which where we'll get into more details and learn about things like congruences and all. Okay.
Yeah.
So maybe in 1 or 2 weeks. So we have around 10 more problems to discuss. After these seven, around 10, 11 more problems are there. So once we finish that, we'll start with divisibility algorithm, congruences, and other topics that you need to know. So just keep trying the problems, try to see how much you can like apply yourself. This is not the same thing as what you have learned in other things. This is totally different. And the way to think is a little different also. So you have to push yourself and try these questions. And remember what we have done in the previous classes. It is the way we have been thinking so far, that's what you have to apply.
Okay.
Okay,
Yeah.
fine. That's all for now. We'll continue next class with geometry.
All right. Thank you.
Bye.
Bye.